Okay, Lila, we are going to do properties of radicals. These are exercises that are directly from you, from your homework. So let's get right into it. So radicals are what? Radicals are the square root sign, right? This guy right here, a square root. So when it says simplify, we're simplifying this expression. Remember, this is an equation, it's an expression. There's no equal sign. When it comes to radicals, square root signs, in this case square root, it could be a cubed root or a fourth root, as we'll see later in some of the other expressions in your questions here. We want to figure out how many, or if there are any squares or perfect squares that we can turn into a whole number. So whether it's 1, 2, 3, 4, 5, which those squares would be what? 1, 4, 9, 16, 25 as an example. If we can find any of those underneath the radical, we are going to try to take it out. Now this, when we have it expressed like this, where we have a division, this is the same as this. We can rewrite this as an equivalent expression. Anytime we have a radical in the denominator, we will eventually want to rationalize it at some point. We want to rationalize it. What's that mean? We want to get the square root out of the denominator. If it's in the numerator, it's fine. If it's in the denominator, that's a no-no when it comes to math. Math people don't like square roots in the denominator, radicals in the denominator. So how do we get rid of that? Well, we can simply multiply the top and bottom by whatever that is. In this case, square root of 52. So let's do that. Square root of 52, top and bottom, will help us get that out of the denominator, the radical. How is that? How are we able to get rid of it with the square root? Well, think about this. What is the square root of 52 squared? What is the square root of 52 squared? It's just going to be whatever is under the radical, in this case, 52. Okay? So anytime we square a radical, or if it's a cubic root, we cube a cubic radical, it's going to be whatever that number is underneath the radical. So now we're good in that there is no radical in the denominator, so we can move forward. So what do we do with the numerator? Well, the numerator, it's just this, right? We can separate them, or we can have them all under the radical. It's 4 times 52. Do we have any perfect squares in that? Well, we know right away this guy, right? That's going to be 2. Why is that? Because the square root of 4 is 2. Square root of 4 is 2. So I know I'm at least going to be able to have 2 there. So 2 can come out, the value 2. What about 52? Do I have any values in 52? Well, let's think about it. If I were to do a factor tree for 52, in In other words, what are some factors? Well, I know it's divisible by 2, right? If anything, why? Because it's an even number. Well, that'd be 2 times 26, okay? 2 is a prime number, so we can't go any further than that. What about 26? Well, 2 on 26 is an even number, so I can do 2 times what? 2 times 13. Prime number, prime number, prime number. So 2 times 2 times 13. Well, 2 times 2 is 4, right? So really I got 4 times 13 in that 52, square root of 52. Well, square root of 4 is another 2, right? So we have another 2 we can take out because that's square root of 4. What about this? Square root of 13. Can that be anything? Nope. It just is what it is. Square root of 13 is what is left over. So out of this 4 times 52, I was able to take out 2 2's and keep the 13 in there. If you want to look at that in a different way, this is really square root of 4 times square root of 4 times square root of 13. So we had 2 2's in there and square root of 13. Or you could look at it this way. Square root of 16, because 4 times 4 is 16, right? Times square root of 13. You could look at it that way. Because we know 2 times 2 is 4, well, square root of 16 is 4, right? Still have in the denominator 52. What does that equal? Well, that's going to be 2 times 2 is 4, square root of 13 over 52. Can we simplify this anymore? Yeah, top and bottom. Actually, we found out from here that 4 can go into 52, right? We can take out 4 on the top and 4 on the bottom. 4 on the bottom is going to be 13. We end up with square root of 13 on the top, because 1 times square root of 13, 13 on the bottom. And that is our answer, square root of 13 over 13. Next one, 1 over square root of 2x. So now we have a variable. We got a variable that we're including into the expression. No big deal. It's the same. The principle still remains the same. We're going to multiply the top and bottom by the square root of 2x. Why are we doing that? Because we cannot have a radical in the denominator. So when we multiply these together on the denominator side, we have square root of 2x squared, which would be what? It's just whatever's under the radical. If we square a radical, it's whatever, or if it's a cubic, we cube a cubic root, whatever is underneath the cubic root, that's what it is. In this case, we have a square because it's square root, so that just becomes 2x. What about the top? Well, it's just 1 times square root of 2x. Can we go any further than this? Well, we actually can't. The temptation would be, well, yeah, it's just 2x over 2x. No, that's not 2x on the top. It's a square root of 2x, right? Because we multiply top and bottom by square root of 2x. So there is actually nothing more we can do with this. It is simplified to its furthest extent. That is it right there, just one step. So that one was a simple simplification. Next one, we have square root of 8 over the square root of 3n cubed. Well, we know already when we have a radical in the denominator, we got to get rid of it. How do we get rid of it? We rationalize it. What does that mean? We take the top, we multiply the top and bottom by whatever that denominator was, in this case square root of 3n cubed. Bottom is going to be what? Square of a square root, whatever's underneath the radical, 3n cubed. So the radical goes away. Okay. Top part. Well, this is the same as this. 8 times 3n cubed. Well, let's multiply that together just to see what that looks like. Well, that'd be 24n cubed, square root of that, over 3n cubed. What can we take out? The top. What can we take out of the top there? We have a square root. Do we have anything in here that we can take out? Well, this breaks down, 24 breaks down into what? 4 times 6. Square root of 4. Square root of 4. What's that? That'd be 2. We could take out a 2. Square root of 6. That's 2 times 3. Those are 2 prime numbers, so there's nothing that's doubled there. So the 6 remains under the square root. How about the n cubed? What is the square root of n cubed? Well, if we think about it, that's n times n times n, right? So we have an n squared, right? We have an n squared. We can take out an n, and we'd be left over with an n. So what is our leftovers in the radical? We have a 6 that we've already established. We have an n, so square root of 6n. That's times 2n. All of that over 3n cubed. Can we simplify any further? Yeah, we actually can. Where do you see that? I see it here. I see an n here, n to the first, and I see there's at least one n here, right? There's actually 3. That goes down to 2. So my final value is 2 square root 6n on the top over 3n squared.